Hey, what's up guys, Yankee here, and in this video we will be talking about function calling in large language models. So this is a very essential topic if you want to build your applications using large language models, because it provides your models with real-time data, ability to do things on your behalf, and so on. And for this tutorial we will be using LangChain, Ollama and Streamlit. So let's look at the demo. For this, we have a very basic application where you can write query to the large language models. For this, I'm going to create a Python function to check if a number is odd. This example basically shows the general use case for large language models. And here is the function. And if you want to do something different, like get real-time data, what is the time in New York? Then I provided this application with a function that it can use to get the real-time data, which is the current time in New York is 5:30. Let's check that with a quick Google search. And indeed, it's 5:30 a.m. in New York. I also have a different function which gets me the disk uses in my computer. So if I ask what's the disk uses, it's going to get the real-time disk uses from my computer and show it here. As you can see, I have total of 1 TB and I have 130 GB left. So these are some of the basic use cases using function calling with large language models. Obviously, you can do a lot of different things depending on your use cases. So let's see how we can build this. Starting off, let's create a project directory called function calling. Let's create a virtual environment. For this, I'm going to use Python 3.11. Activate the virtual environment. And our project dependencies are going to be LangChain, LangChain community, Streamlit, and LangChain Ollama. Let's open our code editor. For me, it's going to be VS Code, but you can use the code editor of your choice. I will create a file called app.py, and I'm going to open VS Code. So first of all, let's start with importing Streamlit as st. And with Streamlit component, I'm going to create a text input area, which is going to say enter your prompt. Let's also import Ollama from LangChain. From LangChain Ollama, import chat Ollama. We are going to create a LLM instance from the chat Ollama, and we are going to pass the model name as Mistral Nemo latest. One thing about function calling is that not all the models support function calling. So I'll leave a link in the description below for the blog posted by Ollama stating which models support function calling. So for this tutorial, you can use Mistral, Llama 3.2, 3.1, and others. Once we have this, let's also import messages from LangChain core.messages import. For now, we are going to need human message, and we are also going to need AI message. So a human message is used to wrap the prompt passed by the user from here. I also need to set a variable here as prompt so I can pass it. And whatever message we get from the LLM, we can wrap it into AI message. Let's also create a messages list, which acts as a chat history for us. I'm going to initialize it empty and put it at the very top. So if we have the prompt, we are going to create the LLM instance, and we are going to add the prompt to messages. So messages.append, we are going to do human message and then pass prompt as part of it. And we will have an AI response from this. So AI response equals to llm.invoke, and we are going to pass the messages to it. And once we have the response, we are going to write it. So I'll create a container for this with st.container. Height is going to be 500, and I'm going to add a border around it so that we can distinguish the result area. And here I'm going to do st.write AI response.content. And this is basically our application that we will start with. Note that we are not passing any functions or doing anything with it. We are just checking the base application right now. Let's run the application. Streamlit run app.py. Yes, we have enter your prompt, and we can add whatever prompt we want. So this will act like a basic large language model. So you can ask anything to it, and if it has the ability to answer that question within its knowledge base, then it will provide a response. Else it does not have any access to the real world data. So I can write a function to generate password using Python. And here we have our response like the regular large language model, which is good. Now let's move on to adding real world data for this application. I'm going to stop the server for now. So for function calling, we need to create our own functions. Let's do that. One of the function would be to get the real-time disk uses from our computer. So I am going to write get disk uses as my function, and it's not going to take any arguments. And for this, the path it's going to use is going to be the root path, and then total used p is going to be shutil dot disk uses and path. For this, we need to import shutil as well. So import shutil, and this will give us our disk uses. We also need to convert the bytes into gigabytes, so it's human readable. So for that, I'm going to do 1024 into 1024, and again the same thing. And after that, we are going to return a pretty nice result which says total, and it's going to be f string total slash GB to convert it to gigabytes, and decimal up to 2 points, and GB. I'm going to copy this, and I'm going to write used for this and p for this. So this is basically the function that we are going to use to get the real-time disk uses of our computer. We also need to pass its context to the large language model, which we are going to do in a bit. But before that, let's create another function which will get the current time across the whole world. So for this, we are going to need a Python utility called zoneinfo. So from zoneinfo, import zoneinfo class, and def, this is going to be get time in time zone, and this is also going to take the time zone name as a string, and then it's going to return a string as well. Let's try current time equals to, oh, we also need to import date time. So from date time, import date time, and once we have that, so date time dot now, and the zone info is going to be whatever time zone is passed here. So this has to be in a IANA format, which is, if you are looking at the time zone for Kathmandu, then it has to be in the format of Asia/Kathmandu and so on. We'll get to this later on. So once we have the current time, we are going to return it in a human readable format. So current time.strf time, and we are going to return year, month, date along with what time is it, the minute, the second, along with the time zone information, which is represented by capital G. And we are going to accept some kind of exception. Basically, whenever the time zone name is not in the IANA format, we are going to raise an exception. So as E, here we are going to return error invalid time zone, and it's going to be str E. So this is done. Oh, this needs to be inside of a string, my bad. We will also need doc strings for these functions, which I'm going to fetch from my example. So this is the doc string, returns the current time for a given time zone. Call this whenever you need to know the current time of any time zone. For example, when a customer asks, what is the time in Kathmandu? As you can read the doc strings, these doc strings are basically for the large language model to understand when they should be calling it. I'm going to do the same for the disk uses as well. Let's paste it. Call this whenever you need to know the disk uses. For example, when a customer asks, what is the disk uses? So we are also passing, like, there are no args, but if you see on get time in time zone, we have one argument, which is time zone, and we also need to specify IANA time zone name, example America, New York. This is particularly to guide the large language model what kind of output it should generate to do the function calling. The next thing we need to do is specify both of these functions as a tool in LangChain. So for that, LangChain provides us with a decorator called tool. So we need to do from LangChain core and tools, import tool. So this tool is a decorator. We can use tool, and what we can do is parse docstring equals to true. You'll know in a second why we are adding this argument here. We need to do the same thing here as well. Now we have two functions that our large language model can use, but we need to pass it to the large language model as a context, like, hey, you have these two functions in your tool build. You can call it whenever you want. For that, I'm going to create a variable called tools list, and this is going to be a dictionary. This will have the name of the function and the function itself, get disk uses, this, and the name of the function. So now we need to create another instance of the chat Ollama, which is LLM with tools. And for this, we are going to bind our tools that we have So basically we are passing the context of our function to the large language models. We do this using LLM.bind tools, and we are going to pass list and just the name of the functions, right? So this is going to be tools list dot values, and this needs to be a list. So we are wrapping all of this as a list. Once that is done, we need to invoke our large language models with tools, not just LLM. So I'm going to replace LLM with tools.invoke. Now we need to check on the AI response if it wants us to make any function calls to get the answer. So for that, we need to check if AI response.tool calls, or even better, if not AI response.tool calls, then I can, oh, I have this extra. Then I can directly stream the output, right? I don't need to do anything if we do not need to do any function calling. I would also write a system exit here. So import sys and sys.exit. But if there are tool calls, what we are going to do is we are going to loop over the tool calls. So for tool call in AI response.tool calls, and we are going to do what tool the large language model has selected. In a bit, we are going to see what kind of response the large language model produces. So selected tool is going to be tools list.get. So this will respond with the name of the tool. We are going to do tool call. It's going to be inside name, and sometimes it can be like uppercase, whatever. So we are just going to add lower for this. AI response. Oh, okay. It's a typo. Let's copy and paste that. Let's say if we are asking for disk uses, it will return get disk uses, and we are getting that function based on the key of the dictionary. And now we are going to invoke the tool ourselves. So tool output, or let's say tool response, to keep it aligned with the rest of our code, we are going to select a tool.invoke, and tool call, it's going to be args. So like I mentioned earlier, in function calling, the large language model provides us with what function to call, what argument to pass when calling that function. So we will get all of that, and our program basically has to capture that and call the function. Once that is done, we also need to add it to the messages. So for this, we need to append our response. I will also need a tool message here because this is a response from the tool. So I'll do tool message, and I'm going to add tool response along with tool call ID, which is going to be tool call and ID. This is an optional thing you can do, but if you have LangFuse or other observability tools, then this will come in handy. Having done this, we also need to add AI message here as well. So whatever AI response we have, we need to messages.append AI response. Invoke message AI response. That's true. We are passing AI. Okay. So once this is done, again, we need to pass the whole message or the chat history to the large language model so that it has the whole context, what the user asked, if we did a tool call or not, if we did the tool call, what kind of response it got, and then what final message to generate based on all of these actions. So I'm going to do final response, and this is going to be LLM with tools again, and I'm going to invoke it. Let's do stream for this, and messages. So stream versus invoke is basically that invoke gives you a static result, like whatever the result is, boom, result. But if you have stream, it's going to stream the result that you see in all the large language models. So we are going to stream for this. So again, st.container height is going to be 500 for this, and border is going to be true. We are going to create a rounded border, and I'm going to write stream and whatever final response it produces. So let's see this in action. I will run my Streamlit application. I'll refresh it again. So I'm going to ask what is my disk uses, and it should fetch my disk uses and hand it over to me. As you can see, I can see my disk uses now. If I ask it anything random, like what is the highest mountain in the world, it will generate the answer from its training data. It's Mount Everest, correct? So let's do another thing. Let's ask it what is the time in Kathmandu. So it should be calling our function get time in time zone and produce the result. It is 4:52 p.m. in Kathmandu. So let's see. I'm going to grab this. this and I'm going to paste it. Yep. So let's see the internals of it. I'm going to add a breakpoint right after our AI response to see what kind of result it produces. And I'm going to ask a question that involves function calling. So I have my terminal on the side. We have stopped right here. We can see the AI response. And here, if you look into tool calls, it has given us the name of the function to call, which is get time in time zone. And the argument will be time zone name, which is Asia Kathmandu. And the ID that we passed was this one. And if you take a look at AI response.tool calls for a closer look, you can see the whole detail. So this is basically large language model telling us, use this function, use this argument, call the function, whatever result you get, give me back the result and I'll give you the final answer. So let's move on. Another interesting thing is that we are going to pass a JSON schema to the large language model. That's how it understands the context of the functions. So to see that, we can actually run this command. So we have a get disk uses function. If you go into arc schema and schema, then it's going to give us the JSON schema that is being passed to the large language models. Since we are using LangChain, all of this is done behind the scenes. So we can just, add tool decorator to our function, say parse docstring equals to true. One of the things that you should notice is that the docstring should be in the Google style. So we need to follow the Google style guide for writing docstrings. Basically, that means whatever is the main goal of the function, you need to write it on the same line where you are writing the triple quotes. You need to mention your args in this format, returns in this format, raises in this format. So if you follow this convention, then when you use parse docstring equals to true, then it can generate the JSON schema that is required to pass to the large language models. So as you can see, description is retrieves disk uses. I'm going to make it a bit bigger. Call this whenever you need to do that. And again, properties is empty because it does not require any arguments. Let's try to see this with another function. Our next function is get time in time zone. For this, returns the current time zone. And in properties, we can see time zone name, description, IANA time zone name, and America, New York. So if we are asking whatever name, we get that. As you saw earlier as well on the AI response, the large language model is intelligent enough to know when I mention like IANA time zone, it gives me in the exact format that I require. I hope this video has been helpful in understanding what function calling is, how it works, and how to implement it on your own application. That's it for this video. Thank you for watching. If you like this video, give me a thumbs up. If you want to see such content in the future, subscribe to my channel, and I'll see you in the next one.